Hello everyone, welcome to the 8085 programming series. In today's session, we will study some program. The first one is divide a 16-bit number stored in memory locations 2200H and 2201H by a 8-bit number stored at memory location 2202. So here we will be performing a 16-bit division, and then store the quotient in memory locations 2300H and 2301 and remainder in memory location 2302. This is what we have to do. So we need to divide this number which is stored at this two memory location by this a number which is at this memory location, and then we will get a quotient. So quotient will be stored at 2300H and 2301 and the remainder at 2302. So let us perform this practical directly on the simulator, and then we'll see what we are getting. Now before performing the practical on the simulator, this is what we'll be doing. Dividing, we'll take we need to take some data. So I'll take this data 0120. So this is the 16-bit number which has to be, this is the dividend, and this 10 is the divisor. So we'll divide this 1020 by 10, and this 1020 is a 16-bit number, so we'll store in this way. So at 2200, this lower byte 20 will be stored, and at 2201 the higher byte 101 will be stored. This is the dividend, and the divisor will be stored at 2202. So we're using 10 as the divisor, and after executing the code we will get this is the result. So at 2300 we'll get the quotient 10, the lower byte of the quotient. At 230 we'll get the higher byte of the quotient, so it is 00 and this is 12, and the remainder will be 0. So which will be stored at 2302. This is the remainder. Now we can also try some examples, like instead of this, if we delete this and make it as 2, then of course the remainder we'll get will be of course 2. You can try that example. Okay, I will do this. Okay, so this is what we'll be doing on the simulator. Now let us do this on the simulator and see what we are getting at each and every instruction. So I have already entered the code into the simulator. This is the code. I will explain each and every line afterwards. And this is the data grid. So I have stored 20 at 2200, 01 at 2201, 10 at 2202. So these two bytes, they are the dividend, and this is the divisor. Now let us go stepwise. Now what we'll be doing in this case is we will perform subtraction. So we will perform division with repeated subtraction, because in case of 8085 there is no division instruction. So we need to do subtraction, repeated subtraction, for performing the division. So let us start. So with the first step, LXI H2200, H will contain 20, L will contain 00, and they also will serve as the memory pointer at 2200. Now with the next step, we transfer the contents of memory location pointed by HL to register A. So this, the lower byte of the data to 20 is transferred to register A. With the next step, we increment the memory pointer and it goes to 2201, and then we transfer the next byte, the higher byte 01, in register B. With the next step, we increment the memory pointer and transfer. With increment of memory pointer, we are at 2202, and here we have the divisor, and with move C, M, the divisor 10 is stored in register C. Now with the next step, we increment B. Now why this step is required? Because in the coming steps we will be decrementing B. Okay, so if B contains suppose 00, and if we decrement B, it will become FF, and we might not get proper result. So we don't know what will be there in B, because now we are knowing that it is actually 01, but if it is 00, then we don't get proper result. So to compensate that particular thing, we increment B. Okay, we'll see this in the coming steps. Now LXI H00 is the next step. So this HL is then initialized to 0000. So this HL will hold the quotient part will be actually stored in this, and then we will transfer it to memory location. So now we are initializing HL to store the quotient. It is 0000. Now next step, we perform the subtraction C. So we are performing A equal to A minus C. As I told that in case of 8085 there is no subtraction, there is no division instruction, so we need to perform subtraction. So we will perform this repeatedly. So subtract C. So C equal to C minus A equal to A minus C. So this 20 minus 10 becomes 10. Okay, then JC. So this is jump if carry. So in case if A would be less than C, then a carry there is a borrow will be generated, but in this case because a was greater, so carry is not generated. Okay. So we increment h because we have performed the subtraction once, so this HL is incremented to show the quotient. So we have done this once. Okay. Then we jump unconditional to again sub C. Okay. We again do the subtraction, so 10 minus 10 will become of course 0 0. Okay. And here carry is not generated, we again increment h. Okay. So and h becomes 0 0 0 2. So this is the quotient is incremented. Okay. So we go on performing the subtraction and go on incrementing the quotient. Okay. Then again jump to 800C. Now with this particular thing, what we see is after we perform this subtract C, so this becomes F0, and here we can say a carry is generated, that is borrow is generated actually. Okay. So here we give the instruction jump if carry to 8014, so now it will go to 8014. Okay. So at 8014 we decrement B, sorry. So here B is decremented. So if you remember in the very few steps we performed INRB. So here we are actually, why we increment, because it may happen that VB was 0 initially. So if we subtract, it will become FF. So we already incremented, so it becomes again, now we are decrementing B, so we are having 0 1. Okay. Now next step checks whether B is 0 or not. So if B is 0, okay, it will jump to 801B. Okay. But because B is not 0, okay, so it will jump to 8010. It would increment H, okay, and jump to 800C again. So it will go on performing the subtraction until A becomes 0. Okay. So this is done, okay, until A becomes 0 again. Okay. And as soon as how many times we are subtracting C, this is actually taken care by HL. So it goes on incrementing this until that A becomes 0. So here again INX H subtract C. So these steps are repeated. Okay. I'll just run this. Now as soon as A becomes 0, it will come out of the loop. Okay. And again it will decrement B. Okay. So let us do this increment, the subtraction C. Now as soon as this A becomes 0, okay, it will jump out of the loop. And so here as we can see, after this DCRB, B became 0, okay, and it came out of the, so jump on 0 to 801B. So at 801B we are adding this C to compensate that whatever subtraction we did before this step. Okay. Now after this step add C, okay, we go to the exchange. Now this, before this exchange, as you can see, this HL 0012, this is the entire quotient, okay, and A holds the remainder, so remainder becomes 0. Okay. So with this XCHG, why do we XCHG? Because we need to store the data to the memory pointer 2300, 2301 and so on. So we need to use this HL pointer for storing the data to the memory. Therefore what we are doing this with exchange, we are actually exchanging the contents of HL with D. So D contained 0000 and HL had contained 0012. So we have just exchanged this content. Okay. So that this we have to initialize the memory pointer to store the quotient and the remainder. So with LXI H2300 we initialize the memory pointer to store the quotient. Okay. So with the next step, move M comma E. So E contains the lower byte of the quotient, so we store this M comma E, so E gets stored here. Okay. And with INX H we go to the next memory pointer, and the D, the higher quotient value, it gets stored at 2301, which is of course 00. And with the next step INX H we go to the next memory pointer and store the remainder. So remainder is 00, remainder gets stored here. So this is how we perform the subtraction. So our data was 0120. Okay. So what we did was we did subtraction with the lower byte, and then we took the 01. If it had been 0220, then this loop would have been repeated 3 times. Okay. So this is how this particular thing is done. We can do one more thing if you want to check this. Okay. Just reset. I will just make this as, instead of 220, I'll just make it 22. Okay. So now in this case, because this is not a proper divisor, it will generate a remainder as 2. Okay. Let us run it. So as you can see, the quotient is 0012 and the remainder is 02. Okay, so this is how we perform this practical. So that's all for this particular session. In the coming videos I'll show some more 8085 programs. So subscribe, like and comment. Thanks for watching.